All right, so we're going to look at part 2 of the Peardeck. So we did this problem on the left, we're starting on the right here, and this is a greater than problem, so it's greater, so we know that our word in between is going to be the word or. Now, before we make our two inequalities, we have to get this absolute value bar alone. So to do that, we need to move this -4 to the other side. So we're going to add 4 to both sides, doing that opposite operation. -4 plus 4 cancels to 0, and we have the absolute value of 5x minus 12 is greater than or equal to 24. So now we can write our two inequalities. So the first one stays exactly the same, but without the bars. 5x minus 12 greater than or equal to 24. Or 5x minus 12, that stays the same, but the greater than or equal changes to a less than or equal to a -24. So we're going to add 12 to both sides, and then we get 5x is greater than or equal to 24 plus 12 is 36, or add 12 over here, and we get 5x is less than or equal to -12. So after that, we'll divide both sides by 5, and I'm just going to write this underneath because I'm kind of getting squished here. So we have x is greater than or equal to 36 divided by 5. That's going to be a decimal. It does not go in evenly. So I'm just going to pull up my calculator and make sure to get that decimal, which is 7.2. And then over here on the right, when we divide by 5, we get x is less than or equal to -12 divided by 5 is a -2.4. And we're not going to graph this one, so don't worry about the graph here. That's why it's blank. But this is our final inequality. So it can be greater than or equal to 7.2 or less than or equal to -2.4. Beautiful. And when you're all set, push ahead to slide 11. So I just want you to take a second here and think about how you're feeling about absolute value inequalities. How do you feel about getting that absolute value part by itself alone? And then how do you feel about breaking it into two separate inequalities and putting that word and or in between? Okay? And thinking about the kiss, right? Keep it and then switch. Beautiful. So you can move that circle to say how you feel, and then push to slide 12, and we'll do a couple more practice problems here. So this first one already has the absolute value completely isolated by itself, so we can just make our two inequalities. So we have, we have x plus 3. The first one is exactly how we see it, is less than -2. Exactly how we see it, except for there is no absolute value bars. And x plus 3, switch, is greater than a +2. So we switched it to greater than, and we switched it to a +2. To solve this, we're just subtracting 3. So we can get x alone, and we have x is less than -5, and x is greater than -1. So we have an open circle on -5 and an open circle on -1, and this is an and. It is greater than -1, and it's less than -5. So we're going to the left of -5, and we are going greater than -1 with our open circles. Beautiful. Oh, and this one, when we look at this, we can't have something that is over on the left and over on the right. So this is actually a case, because it can't be in both parts of the arrows, so this is a case of no solution. And the reason we have no solution here is because it's saying that this absolute value is less than -2. But when we take the absolute value of any number, it becomes positive. So it will always be greater than a -2. So this will not work. We can't be less than -5 and greater than -1. That doesn't make sense. It's not going to work. There's no solution where it can be in both parts of those arrows. So this is no solution. Beautiful. Over on the right, we want to get our absolute value part alone. So the first thing we're going to do is we're going to add 1 to both sides. And then we have 2 times the absolute value of -2x plus 3 is greater than or equal to 2. And then we're going to divide everything by 2 to get that completely alone. So we have the absolute value of -2x plus 3 is greater than or equal to 1. Now, at this point, we have our absolute value alone and isolated. So we can write our two inequalities. And I am running out of space here. And I don't want to squeeze it in because I want to make sure you can see how I'm getting it. So the first one is we write it just as is, but we get rid of the absolute value bars. And then we'll solve. We subtract 3 on both sides to get -2x greater than or equal to -2. Oh my gosh, why is it doing that? And then we divide by -2. Of course, remembering when we divide by a negative, we flip that symbol to get x less than or equal to 1. And our second inequality is -2x plus 3. That stays the same, but then we switch. So we make it less than or equal to and a -1. And again, subtract 3 to get -2x is less than or equal to a -4. And when we divide by a -2, we flip the sign and get 2. And this started as a greater than symbol. So we use the word or. And we want a closed circle on 2 and a closed circle on 1. So it can either be greater than or equal to a +2 or less than or equal to 1. And there's our disjointed compound inequality. Okay. Go ahead to slide 13 when you're ready. So for slide 13, to get us started on the left, we need to just make sure we have the absolute value alone. So we're going to add 3 to both sides, and we get the absolute value of 2x plus 1 is greater than or equal to 9. 6 plus 3 is 9. And then we can write our two inequalities. 2x plus 1 is greater than or equal to 9, or 2x plus 1 less than or equal to a -9. Switched it to less than, switched it to a -9. And now we have our two inequalities. When we subtract 1 on both sides, we get 2x is greater than or equal to 8. Or 2x subtract 1 is less than or equal to -10. And then we'll divide by 2 to get x is greater than or equal to 4, or x is less than or equal to -5. So we have a closed circle on -5 and a closed circle on 4. We are greater than 4, so we're going to the right from 4, or less than or equal to that -5. For the next one, to get us started, we want to move this plus 2 first, so we're going to subtract 2 from both sides. So we have, my mouse is being weird, we have this 3 times 2z plus 5 is less than or equal to 6, right? 8 minus 2 is 6. And then we will divide both sides by 3. So we have 2z plus 5, absolute value of that is less than or equal to 6 divided by 3 is 2. And now we can write our two inequalities. First one stays the exact same, 2z plus 5 less than or equal to 2. And 2z plus 5 greater than or equal to negative 2. Okay? When we subtract 5 on both sides, we get 2z is less than or equal to 2 minus 5, which is a negative 3. And 2z is greater than or equal to negative 2 minus 5, which is a negative 7. Okay. So the next thing we're going to do is divide by 2. So we get z is less than or equal to negative 3 divided by 2 is a negative 1.5. Okay. And z is greater than or equal to negative 7 divided by 2 is a negative 3.5. So when we put our solid circles here, negative 3.5 is going to be right here, and negative 1.5 will be here, and we are looking for that area in between that's less than negative 1.5 but greater than negative 3.5. Brilliant. Once you got everything that you need here, push to the next slide, slide 14. This says the average January temperature in a northern Canadian city is 1 degree Fahrenheit. So cold. The actual January temperature may be 5 degrees warmer or colder. So it could be 1 plus 5 or 1 minus 5, right? And we can represent that as an absolute value inequality. So if we let x equal the temperature in January, that temperature, when you look at the difference between that temperature and 1 degree, it should be less than or equal to 5. And the two equations we would create from that are x minus 1 less than or equal to 5 and x minus 1 greater than or equal to negative 5. So when we add 1 to both sides, we get x is less than or equal to 6, which makes sense. It could be up to 6 degrees. And when we add 1, x is greater than or equal to negative 4. So we have one of our values on negative 4 and the other value on 6. 3, 2, 1, 0. 1, 2, 3. There's our negative 4. We want to do closed circles because these are greater than or equal to and less than or equal to on 6, oops, and on negative 4, and we're looking at that space between. Beautiful. And on slide 15, I want you to try slide 15 and 16 on your own. So on slide 15, you're going to try and write an absolute value inequality using this bag of chips and use what we did on slide 14 to get an idea on how to set that up. And then on slide 16, you're matching one of these inequalities and one of these graphs into each of these categories. So try your best working through this. You got it.